Hi guys, welcome to the post-contest discussion of today's Codeforces contest. The contest was from 2:30, which was kind of unusual time, but I guess it's perfect for Sunday because 2:30 to 4:30 you can give the contest and then you're free rest of the day. So let's start with the contest. We'll be discussing problems A, B, C, D, which is div 2 AB and div 1 AB. All right. So let's have a look. The first problem is a really good problem in terms of mathematics. So let's have a look. Alice has A coins. She can open a bank deposit called profitable. But the minimum amount required to open this deposit is B coins. There is also a deposit called unprofitable, which can be opened in any amount of coins. Alice noticed that if she opens the unprofitable deposit with X coins, the minimum amount required to open the profitable deposit decreases by 2x coins. However, these coins cannot later be deposited into the profitable deposit. Help Alice determine the maximum number of coins she can deposit in the profitable deposit if she first deposits some amount in unprofitable deposit. Okay. If it's not possible, then print 0. So guys, what does the problem say? The problem says that you are given two integers a and b. All right. This is the starting amount that you have, and this is the amount required, like minimum possible deposit for the profitable deposit. All right. The other thing that is said in the problem statement is that for every 1 rupees that you put in the unprofitable deposit, all right, the cost of the profitable deposit reduces by 2. Yes or no? B becomes B minus 2. We want to know what is the maximum possible value we can put in the profitable deposit. Yes or no, guys? This is the problem statement. Okay. Let's have a quick example. Let's take 10 and 5. All right. So guys, if we take 10 and 5, initially we have 10 rupees and the minimum possible deposit for the profitable deposit is 5 rupees. So since 10 is greater than equal to 5, we can put the entire 10 rupees here. Okay. Now let's look at 7 and 9. Okay. 7 and 9. Guys, do you agree that currently 7 is smaller than 9, so we cannot deposit in our profitable bank? So what we'll do, we'll deposit 1 in the unprofitable bank. So when we deposit 1 in the unprofitable bank, the number of coins we have remaining reduces by 1, it becomes 6, and the barrier reduces by 2, so it becomes 7. Now similarly, you can see that 6 is still smaller than 7. We'll need to apply this again. So you can see that this becomes 5 and this becomes 5 as well. Since 5 is greater than equal to 5, we can say that we can deposit 5 rupees inside our profitable deposit. Is the problem statement clear for everyone, guys? Okay. Now, how do you think about this problem mathematically is something that I'm going to teach you all. Guys, consider that you have to perform X operations. Okay, you have to perform X operations before the money you have left, the money left becomes greater than equal to min deposit of profitable. Okay. In this case, guys, do you agree that we would put all the money left inside the profitable deposit? Yes. Guys, if we perform X operations, what is the amount of money left? A minus X. Yes or no? If we perform X operations, the money left with us is A minus X. Now, guys, what is the min deposit? B minus 2x. Yes. So our goal, guys, is to find this a minus x, and we already have uh, b and a. So what we can do, guys, we can first find x. And how can we find x? A minus x is greater than equal to b minus 2x. So we can add 2x on both sides. So a plus x becomes greater than equal to b. So can you say, guys, x is greater than equal to b minus a? So the smallest value of x is b minus a. Yes or no? Now, guys, the value we had left is a minus x. If we substitute the value of x here, it becomes a minus b minus a, which becomes 2a minus b. Yes or no, guys? Isn't this the minimum? Like, isn't this the money left with us before the money left becomes greater than equal to the min deposit? Yes. Now, the only thing that we can say is, guys, this can also become negative. All right. So, guys, when this value becomes negative, can we say it's never possible to deposit inside the bank? Yes. So, guys, we can just print maximum of 0, comma 2a minus p. And this right here is our O of 1 solution for problem A. Is this much clear for everyone? Great. So if that much is clear for everyone, let me just share the code with y'all. You can look that we take an int a, b, c in a, b, and just see out maximum of 0, comma 2a minus b. We don't need int long because 2a can be 2e9. I hope this much is clear for every one of y'all. If that much is clear for every one of y'all, let's move on to problem B. Okay. What does problem B say? There is a vending machine that sells lemonade. The machine has a total of n slots. You know that initially the ith slot contains AI cans of lemonade, but there are also n buttons, each corresponds to a slot. And whenever you press it, there are two things that happen. Either when you press a button, the slot which it is corresponding to, if it has a can left, it will dispense that can. Otherwise, it will dispense nothing. Okay. You want at least or equal to k cans. Okay. We want to know what is the minimum number of button presses we are going to require so that we come to know if if we can get k cans or not. Okay. So let me just explain the problem statement again for people who haven't understood. So the second problem is as follows. We have a vending machine. Okay. Let me just draw the vending machine. Okay. And this vending machine right here has n buttons. Okay. It has n buttons. Okay. Now each of these buttons internally, okay, each of these buttons internally is connected to some slot. Okay. For example, let's say this is a 1-to-1, like simple correspondence. And each slot currently has AI cans in it. So this is A1, A2, A3, and A4. Okay. We require K cans. Okay. Whenever we press a button, guys, whenever we press a button, if there is a can in that particular slot, then there will be one can which is dispensed and the number of cans reduces from here. Otherwise, if this becomes 0, if there are no cans in here, then you get nothing. Okay. Like it will just say that no cans available or something like that. Okay. This is the problem statement. We want to know what? We want to know the minimum button moves or minimum button presses before we get K cans. Yes or no? Like what is the minimum number of button presses we will have to do? Assuming that we do not know this, we don't know which button corresponds to which particular slot. So we would do that. All right. So guys, let's take a small example and see how this problem works. Like if I if you intuitively think about this problem statement, it shouldn't be so hard. So let's look at 2 1. Okay, there are two slots, each with one can initially. Okay, and you want, let's say you want one can. Okay, now guys, when you want one can, do you agree you can press any of these two buttons? Okay, and it will give you a can, yes or no? So in one move we are able to do this, correct? Okay, now guys, let's change it. Instead of one, let's say we wanted two cans. All right, do you agree I can press any button first, then I can press any button, and then we would have two cans, yes or no? Yes. So in that case we would have two moves. Now let's spin things up a bit. Okay guys, let's say this is 1 and 2 and we need 3 cans. Okay, now what happens? What approaches do we have here? Guys, do you notice one approach is we can keep pushing a particular button till that slot becomes empty, yes or no? For example, and we have to always consider the worst case. So consider that we picked up this particular can, we pressed it one time, we got one can, we pressed it again, we got empty. So we have wasted two. After that, we press another two times on the other can, and then we would get another two. Yes or no? Like here we would press another two times, and in four moves, we are able to get three cans. All right. But guys, this approach fails in certain cases. Let me show you all in which case this exactly fails. Okay. Consider this is the slots we have, which is 1, 1, 2, and k is equal to 3. Okay, guys. If we use the same approach, we would press this two times, we would get one. We would press this two times, we would get one. And we would press this one time. So we have used 2 plus 2 plus 1, which is 5 moves. If we use this approach, like we press the smallest one, sometimes then smallest, the second smallest one, third smallest one, so on and so forth. Yes or no, guys? Isn't this? It'll take 5 moves. But there is a better approach to this, guys. Okay, consider the smallest one right now that we have. Okay, do you agree that all other slots have greater than equal to 1 cans? Yes or no? So do you agree that we can press each button one time? Okay, and we would get 3 cans. Yes or no, guys? And we have only used 3 moves to do so. Clear with everyone? What did I say, guys? Let's say we sort the cans. Okay, we know that one has one has one, and one has two. When let's say we are on the worst can. Okay, since the worst can has only one slot has one can, we can press each slot one time, and we are sure that each of them is going to dispense at least one can. Okay, now after that, guys, let's do this again starting from here, because we want to dispose this. Let's say k is equal to 4 here. Okay, guys, now notice we spent 3 moves and we got 3 cans. Okay, now this became 0, this became 0, and this became 1. Yes or no? But do we know that this is empty or this is empty? No, right? So we are going to spend one move over here. Okay. We are going to spend 4 moves total. Then let's say we go over here. Okay. After that, we don't know this is empty. So let's say we press this. We spend one more move, which is 5 moves in total. And now we know that these both are empty. Now we go to this final and press it one time. We get 4 cans, and that is what we required. So my answer here is 6. Is this much clear for everyone? Yes. So guys, let's come up with a general approach, right? What is the general approach, guys? That consider you have, oops, 1 second, guys. Sorry for that. So sorry. So guys, consider that you have the cans in sorted order. Okay. 2, 3, 3, 5, and 7. 7. Okay. This is index 0, this is index 1, this is index 2, this is index 3, and this is index 4. Okay. Since this is in sorted order, now guys, what can we do? Since we know the minimum is 2, do y'all agree we can press all the slots 2 times and we would get 10 cans for sure? Yes or no? Yes. After this, if k is greater than 10, do you agree we'll have to waste one move over here? Correct? To dispose this. So we have used 10 cans. This became 0, this became 1, this became 1, this became 3, and this became 5. Okay. So we have used 11 moves. All right. Then we go on to the next slot, the next smallest slot, because we are considering the worst case. Now, since this is 1, do you agree we can press all these at least 1 times? Yes or no? All these 4 1 times. So guys, for up till 14 cans, this was 10. For 14 cans, it is 15 moves. Yes or no? One for this, and then one that we wasted, and so on and so forth. Okay. But let's say k is even greater than this. So this became 0, this became 0, this became 2, and this became 4. Okay. So 0, 0, 2, and 4. Okay. Now, if k is greater than 14, we would have to spend one move here. We would again have to spend one move here. So we spent 17 moves. And after we have spent 17 moves for 14 cans, we are now over here. Since the smallest number of cans is 2, do you guys agree that for both of these slots, we can press it 2 times and 4 cans will come out? Yes or no? So guys, for 17 plus 4, which is 21 moves, in 21 moves, we can get 18 cans. Is this much clear for everyone? And so on and so forth. So what we can do, we can run this simulation, guys, till the number of cans we have got is smaller than k. We can keep running this simulation. Is the solution clear for everyone what we are trying to do? We start from the smallest element. We can say that all the elements we can press this much times. Then we subtract that much from all the elements. And then we go on to the next element. So let me just show you all the implementation of the same. Okay. So we have n, we have k, and we have subtract is equal to 0. Okay. Subtract basically means how much is the current value of AI. My answer is initially k. Why is this initially k, guys? Because we are at least going to require k moves. Okay. So we take an input and then we sort it. Then we iterate in sorted order. Okay. AI minus equal to subtract. What does this mean, guys? If we have already iterated through, let's say 1 and 2, do you agree AI has reduced? Like, let's say we are at the third smallest element. We have already performed some operations, right? So the actual number of cans left in that slot has reduced. So we update the number of cans we have. Okay. Now, guys, all the slots that are towards the left, we can have that many cans. So we can have minimum of k, comma, n minus I into ai cans. Yes or no? So I subtract the number of cans that I need by minimum of k, comma, n minus I into ai. Is this much clear for everyone? Subtract the number of cans we can get. Yes. After this, if k is equal to 0, basically if we have got all the cans, we break. Otherwise, we do answer plus plus. Why do we do answer plus plus, guys? Because we waste a move discarding this slot. That is, this slot is empty and we want to know. All right. And in the end, we just increase subtract by the number of operations we have done. So when we go to the next particular element, we reduce that many times from that particular element and go ahead. Basically, what I'm trying to tell you all is, let's say the array is 335. Okay. So when we are on the smallest slot, we perform 3 operations on each of the array. So the array becomes 002, right? So when we go to the next element, the number of cans remaining is not 3, it's actually 0. That is why we have to maintain this subtract. Is this much clear for everyone? So a very simple simulation based code where you take in input, you subtract the number of cans that you have already performed, then you subtract the number of cans you can get, which is minimum of k, comma, n minus I into ai. And after that, if k is equal to 0, basically the cans that you require have become 0, then you just break. Otherwise, you do answer plus plus because you're wasting a move on this particular slot. Okay. Harsh says, can you explain that once? Harsh, what do you want me to explain? 335, sure. And what is k? What do you want k to be? Okay, k is equal to 10. So Harsh, do you agree that initially we can have like the number of operations that you're going to have is going to be at least 10. Okay. So your answer is initially 10. Now we start at this particular index, which is 3. Do you agree for all of these 3 elements, we can remove 3 cans each from each of these slots? Correct? So you remove 9 of the cans. So the number of cans you want now becomes 10 minus 9, which is 1. Yes or no? Yes. And the answer remains as it is. Okay. Since k is not 0, do you agree you will have to discard this particular slot? Okay. Since you will have to discard this particular slot, do you agree you will have to perform one extra move to know if it is empty or not? Yes. So the answer becomes 11. Okay. Now subtract becomes equal to ai. So subtract was initially 0. Now subtract is equal to 3. Why is it equal to 3? No, we'll be doing ai minus subtract, no, Manjunath. Like you'll have to maintain the previous value, then do subtract and then set it. Like you can do that. Like it's the same thing. Like you'll have to write 2 lines for it anyways. Okay. So since subtract is equal to 3, when we go to the next element, this has already become 0. Okay. Do you agree the number of cans remaining here has become 0 as well? Because we performed 3 on each of the cans. So Do you agree we'll have to waste a move here as well? So since we'll have to waste a move here as well, okay, in that, oh, this, yeah. So in that particular case, the answer will become 12. Okay. And after answer becomes 12, we add this AI to subtract. So subtract remains 3. And once we are here, we do 2. And do you agree? Here we can press this one time and then this will become 0. Yes or no? Yes. So since this is 0, we break and then we just print the answer. So can you tell that it requires 12 moves to get 10 cans, which is okay? Okay. Devan says, what is subtract doing? Basically, subtract tells us like if we have performed three, so we have performed 3 operations on each of them, right? So when I come over here, what is the actual value of it? It is 3 minus the number of operations I have performed previously, which is 3 minus 3, which is 0, right? How do you know that this is not 3 and it is 0? By maintaining the number of moves you have performed. How many moves have you performed? You have performed subtract number of moves. Okay. Is this much clear for everyone? Hemang says yes. Harivardhan says yes. Okay. What about Devansh? Okay. Amazing. So that is more or less it for this particular problem, guys. I hope you were able to understand it. Like we can have it like this as well. Like I just wanted to make it much simpler for you all. You can maybe have answer is equal to 0. And after having answer is equal to 0, you can do this. Like you can do answer plus equal to this. So what this would help you is 160. This would help you to find the number of operations. Okay, so you can update the number of operations in real time as well. So it's completely up to you. I felt that it was more intuitive writing answer outside. So that is why I wrote it outside, but it's completely up to you. So is this much clear for everyone? Great. So if this much is clear for everyone, guys, let's move on to problem C. Problem C is a good problem. And I also got stuck, like I didn't prove my solution for quite some time. But after you do it, then it is very, very simple. Okay. You are given n arrays A1, A2, AN. The length of each array is 2. You need to concatenate the arrays into a single array 2n such that the number of inversions in the resulting array is minimized. You note that you do not need to count the actual number of inversions. More formally, you choose a permutation P of length n such that there are as few inversions as possible. Okay, guys, this is the problem that is given to us. Okay, what does the problem say? You are given some pairs. Okay, let's assume that it is 1 comma 4 and 2 comma 3, 1 comma 4 and 2 comma 3. You need to sort these pairs in some particular order. Let's say 2, 3, 1 and 4, such that this resulting array reduces the number of permutations. Okay, guys, this is the problem statement that is given to us. Before moving on, I would like to know how many of you all were not able to solve this problem. Okay, so guys, okay, let me ask you very simple things and then we can move on to the solution. Okay, so guys, let me ask you this. Let's say instead of pairs, okay, Let's say you are given single elements 1, 3, 4, 2, and your aim was to sort it. Okay. Do you agree that you would like to sort it in ascending order? Yes or no? Yes. Okay. What does this mean, guys? We would like the larger elements to be as right as possible and the smaller elements to be as left as possible. Yes or no, guys? Yes. So, why cannot we extend the same idea? Hers is why? Because that, that is how number of inversions is defined, hers. Like, you will have number of inversions equal to 0 when you sort an array in ascending order, right? Like, because the number of inversions is the number of pairs I comma j, such that I is smaller than j and ai is greater than aj. If you see, if you sort it in ascending order, then there are no um, things. Now, guys, let's look at some thing like 3, 2, 4, 3, and 2, 1. 3, 2, 4, 3, and 2, 1. Okay. Now, guys, I want you all to answer me something. Okay. If you look at these particular pairs, do you agree the largest element uh, right here is 4? Correct? Regardless of what this element is, if this was a 4, if this was a 2, if this was a 1, if I keep this 4 comma x as my first element and I keep all others on the right, do you agree that this is the worst case? Because since all elements are have smaller elements than 4, the number of inversions would increase by a lot. Yes or no? So, guys, can we say that keeping this, the one with the largest element, towards the right is good for me? Yes. Okay. Now, let's look at the other two elements. Okay. What is the max among them, guys? 3. Okay. So we have 3 and we have 2. Do you agree if I keep this 3 comma 2 here, then it would increase my number of inversions because I would place this to the right of it? Yes or no? So do you agree I would like to place 3 comma 2 here? Now similarly, I have only one left. I would like to place 2 comma 1 here. So guys, what do we notice? We notice that the one which has the largest value should be the rightmost element, because we are reducing the number of inversions the most by placing it towards the right. Once we have placed it towards the right, we can solve for the other prefixes. But you might ask me, no, like, yeah, we will sort, but in a particular way. You might ask me that what if, okay, what if it was 4 comma 3 and then it was, let's say, 4 comma 1 or 1 comma 4. Okay, 1 comma 4 and 4 comma 1 doesn't really matter. Which one would we have towards the right? Okay, so guys, when we have two elements that have the same max, do you agree you would like to have the one towards the left which has the smaller number? Yes or no? The other number which is smaller, that is the pair you would like to have towards the left. Basically, here we would like to have 4 comma 1 and after that 4 comma 3, because these two are the same. But if we have 4 comma 3 and then we have 4 comma 1, can you see the number of inversions increased? But in that case, this pair was not increasing. Yes or no, guys? Okay. So, do you agree that these are the only two cases that matter to us, guys? We can greedily place the elements, pick up the maximum element. Let me choose some other color. Okay, let me choose, let's say, purple. We choose the maximum element, place it on the right. Then we choose the second maximum one, place it on the right. Then we choose the third maximum one, place it on the right. So on and so forth. And in the end, we'll come up with our array. Correct? So guys, I want to ask you all one thing, that what are we sorting this array on? Tell me guys, what are we sorting this array on? The max of AI dot first, comma AI dot second. Yes or no, guys? Tell me. Isn't this the value on which we are sorting it on? Yes. So if both of them are same, like AI dot first and uh, bi dot first maxes are same, then do you agree, like if the maxes are same, then we sort on min, otherwise we sort on max? Yes. So this is the only thing that we need to do. We need to sort on maximum value of AI dot first and AI dot second, and this we can do with the help of a custom comparator. Okay. So the only thing you need to do in this particular problem is write a custom comparator on max, and that will help you solve this problem. You take in your array of pairs, and after that, if max, both the maxes are same, then the one you return true. If the minimum is smaller, like the one on the left hand side, if it has the smaller minimum, you return true, otherwise you return false. Otherwise, you want to have A on the left if it has the smallest max. So you just write a custom comparator around this, and in the end, you print all the values. A very, very simple to understand code. Okay. Uh, Sir, what if we have 1 comma 100 as one pair and others are 2 comma 3? You would have 1 comma 100 towards the end. Okay.
Hello, sir.
So, guys, yes.
Sir, we sort on the basis of the minimum element, right?
No, the max element.
Oh, so max element is at the last right side of the part.
Mm, mm. We are
So max,
considering the max of both of them. Yes or no, Kal? So max of
yes,
1 comma 100 is 100, correct?
yes.
So do you agree we would have 1 comma 100 towards the right?
Acha, got it, sir.
Okay.
Sir, can I say my approach during the contest? Like,
Sure, like let's just discuss D, and we can definitely then take up a discussion session after the PCD. Okay, I'll be there for around
okay,
30 minutes.
okay, sir.
Okay, so guys, this is just a very simple custom comparator. If max elements are same, then sort on min. Otherwise, you sort on the max element. Let me just keep this here and sort based on the max elements out of the two, because we would like to have as large elements on the right hand side. Is this much clear for everyone, guys? Like it's just a 3-line answer, but coming up to this is quite tricky because you kind of need to understand how inversions work. And if you're able to do that, you will realize that you would like to have the larger elements on the right hand side. So that is why you sort on the max elements out of the two. Clear for everyone? What made you go wrong twice? Yeah, I was doing some random things here and there. So it took me a while to get back to my senses. But yeah. So if this much is clear for everyone, let's move on to the next problem, which is my favorite problem of the problem set. Out of what I have solved, I was only able to solve A, B, C, D, unfortunately. Uh, E was relatively very hard. So let's see. You're in the year 3024. Ideas for problems have long run out, and the Olympiad tasks uh, place in modified individual format, numbered from 1 to n. The ith problem has its own score AI and a certain parameter BI. Initially, testing system gives the participant the first problem. When the participant is given the ith problem, they have two options: submit the problem and receive AI points, or skip this problem and never be able to solve it again. If they skipped the ith problem, then then the judge will look at problems for all j smaller than I. Otherwise, if the person skipped the problem, then uh, the judge will look at all problems j smaller than equal to bi. We need to find the maximum number of points that can be achieved. Let me just reiterate the problem for you guys. The problem says that you are given n problems. Okay, you are given n problems. Problem 1, problem 2, problem 3, so on and so forth up till problem n. Each problem has two values: A1, B1, A2, B2, A3, B3, and so on and so forth. Okay. Now, guys, what does the problem say? You are initially given the first problem. Okay. You have two choices. Either you can skip this problem or solve this problem. If you skip this problem, okay, let's say this bi was 3. Okay, if this bi was 3, all the indices up to here become unlocked, and this you cannot solve anymore. Okay, but if you do solve it, then you will go backwards, but you will receive plus a1 number of points. And based on what you have unlocked, the judge will give you the next problem. What will be the next problem? The rightmost problem that you have not solved. Okay, so you have two choices: either to submit on a particular problem, or you can skip the problem. If you submit on the problem, you will receive plus AI points, and then you will go to all j that is smaller than I. Otherwise, you will receive plus 0 points, and now you will go to all j smaller than bi. Is this much clear for everyone? Yes or no? Okay. So if this much is clear for everyone, guys, let's look at this first. Let's analyze the nature of this problem, and then let's come up with an approach. Okay. So guys, let's say you are at index I. All right. If you make a submission, okay, if you make a submission, you will receive plus AI, and then you will go backwards. Yes or no? Correct? Now, if you do not solve this, and let's say for now, bi is greater than I. Let's assume this, okay? It doesn't really matter, but let's assume this. If bi is greater than I, does it mean that by skipping this particular problem, okay, by skipping this particular problem, you were able to unlock more problems? Yes or no, guys? Tell me. Yes. So we have two options. Either if we submit, okay, we would keep going backwards and pick up all the problems. Otherwise, if we skip this, then we would go forward. So, guys, do you agree? Okay, do you agree that in our most optimal case, basically the one which the judge gave us, I'm emphasizing on the things that I'm telling you all. Like, how do you think around these problems? You think that, okay, if this is the most optimal solution, then what could have happened? So, in the most optimal solution, guys, do you agree you will unlock till a particular index I, okay? And after reaching that index I, you will start taking all the elements, like let's say you skipped this and this, and you unlocked all of these, okay? So you will take this, and take this, yes or no? What I'm trying to say, guys, is in our optimal solution, till a particular index, you are going to unlock all the elements till that index. And let's say you used some of the elements to unlock till there. So your final score is what, guys? Your final score is just sum up till AI, sum up till index I. Okay. Basically, the sum of all these elements minus the one used to unlock it. Yes or no, guys? For example, if you use this problem and this problem to unlock all these five problems, do you agree the score that you can get if your last problem that you solved was this fifth problem, the sum of all these elements minus the ones that you used to unlock them? Is this much clear for everyone? Okay. So now, guys, how do we solve this? Okay. If for every index, okay, if for every index I, okay, we are able to store, it is kind of like prefixum, but it is not. If for every index I, we are able to store the minimum cost to unlock this index, okay, let's represent it by a variable x. Do you agree if we ended at index I, our score would be sum of, okay, sum of all indices from uh, 0 to capital I. Okay, let me write this as capital I, AI minus x. Yes or no? Tell me, guys. Does cost mean the sum of the nodes we are? Yes, yes, exactly. The ones which we skipped. So let for every index I, if we are able to store the minimum cost that we use to unlock this index, then we can say that if we end at this index, the score would be AI minus X. Is this much clear for everyone, guys? Yes, clear for everyone. So now our task is what? Our task is to calculate the minimum cost to unlock every index. Mohit says y minus x because this is the cost that we lost, right, Mohit? Like we need to subtract the cost that we lost. Okay. What is summation here? It's the sum up till here. If I wanted to know what is the score, if I ended at this particular index, it is the sum of elements up till here minus, oops, minus the ones that we skipped, right? So this plus this is x, and then this is summation ai. Okay. Now, if this much is clear for everyone, guys, our task is to store the minimum cost to unlock every index. Okay. Now, this right here, guys, this right here can be easily done. And let me show you all how. Okay. Let's say, okay, let's say we are having a cost array. Okay. Where the cost, where this like cost array, where the ith index stores the minimum cost to unlock everything up till the ith index. Okay. Let's say somehow you are able to get this index, this value, which is x. Okay. And initially everything has some values right here, right? If you are on the ith index, guys, and you know the minimum cost to unlock it, do you agree now you can also unlock everything in the range 0 to bi minus 1? This is one based indexing. That is why I do minus 1. So do you agree we can unlock everything in the range 0 to bi minus 1 with an additional cost of ai? Basically, since we are skipping it, it is costing us ai score. So do you agree if bi is, let's say, 5? Okay. So we can unlock the first 5 elements with cost x plus ai. Yes or no? Tell me, guys. Yes. What about others? Okay. Now, what do you mean why, Himang? You can feel free to unmute and
Sir,
ask.
why it
Yes.
will be plus AI?
Because we are losing that score, no?
But uh, it will not be plus BI.
No, no. BI is the range given to us. It is not the cost. If you, let's say, you are skipping this problem, then how much are you not making, Hemang? If you had solved this problem, you would get plus AI. But if you're not solving this problem, you will get plus 0. Yes.
Yes, sir.
So do you agree you lost AI?
Yes, sir.
Okay.
Yes, sir.
So let's say, let's say the minimum cost to update this was X. Okay. And now do you agree the cost to unlock everything has a potential new cost, which is X plus AI. So for everything in this range, can I set their cost of J to minimum of cost of J, comma, X plus AI? Yes or no, guys? Because I know to unlock all these indices, uh, I can do that for sure in X plus AI cost. So I can set cost of J to minimum of cost of J, comma, X plus AI. Is this much clear for everyone? Think of it like some sort of Dijkstra where there is a edge from here to all these particular elements. So if you are trying to unlock all these elements through this particular node, you would incur a cost of X plus AI. Yes or no, guys? Mohit says, but sir, we can only take max of all available index. What do you mean? Yes, yes, Mohit. So I'll prove you that part as well. But is this much clear to you? Like, if I have the cost required to unlock index I, do you agree I can unlock every other index in the range 0 to bi minus 1 with a cost of x plus ai, because x was the cost required to unlock index I, and then plus ai if you skip the ith index. So the cost of all j in that range would be minimum of cost j comma x plus ai. Yes or no? Yes. Okay. Now, by doing this, do you agree we are updating all of these nodes cost? Yes. So if we have one cost, we can update all other cost. Yes. Okay. Now, guys, let me ask you all something. Is there, like I told you all, if we know one cost, then we can update all other cost. Is there one cost that we know from this entire array beforehand? Let everything else be infinity for now. Exactly. The cost of unlocking the first problem is 0. Yes or no, guys? Yes. So the cost of unlocking everything in the range 0 to b0 minus 1 is going to be 0 plus a0, right? So let's say this. So we update everything in this range, whatever b0 minus 1 is, to the minimum of itself, comma, a plus a0. Okay. Now, guys, this, let's say this gets updated to 2. Let's say a0 was 2. Okay. Now I want to ask you all, can we reduce this to smaller than 2 ever? Let's say you used no. Why? Why can't we reduce this to smaller than 2?
Because we will always add another AI.
Exactly. Amazing. So no matter what you do, guys, if you would say that, let's say we would unlock this using this, right? But do you agree to unlock this? You would need to add some AI to this. So it would be 2 plus something. So the minimum cost for this would always be 2. So then we go to the first index. Okay. Then we what do? You update the other range what to whatever it is 2 plus a0, and you keep doing this. Then you go to the third index and so on and so forth. After you do this, guys, do you agree for every index you are going to have the minimum cost required to update it? Yes or no? Yes. But the thing is, this right here, what we are trying to do, we iterate over all indices from 0 to uh, bi minus 1. It would be O of n square. Yes or no, guys? For every element, we can, I think, do it using 2 pointers as well. But for every element, uh, we are more or less updating n times. So it would be O of n square. But what do we need to do? Okay. You are given an array, and in a particular range, you need to set all the elements to minimum of itself, comma, some value v which is given to you. Yes or no? You need to do this a lot of times. This right here can be done using a lazy seg tree. Okay, guys? This is a very standard technique. Okay, using a lazy segment tree. I think it will be covered in level 4. You can do these sort of operations. So if you are able to do these sort of operations using a lazy segment tree, and you are able to get all these values, do you agree in the end we can just iterate over all I and say that your answer is nothing but maximum of answer, comma, sum from 0 to I, okay, 0 to I minus cost of I. If we do this for all I, do you agree in the end we are going to have our answer? Yes? Is this much clear for everyone? So that is more or less the solution. Like this is a very simple, easy to understand solution. So you take in A, you take in B, and after that you have your segment tree. So initially the cost for 0, you set it as 0. So 0 to 0, you set it as cost 0. So whenever I use update, this is L, this is R, and this is a value which we want to update. So your sum is 0 and your answer is 0. Sum plus equal to AI because I want the sum up till the ith index. Query is equal to tree dot query I comma I. So this will give me the cost of the ith, the cost required to unlock up till the ith index. Okay, I'm not maintaining an array of cost. I'm doing it directly using the tree. Now, if query is equal to long max, it means that I cannot unlock it. So I just break. Otherwise, answer is equal to sum, which is sum up till the ith elements minus the cost required to unlock till here. After that, you do tree dot update 0 to bi minus 1 and cost will be query plus AI. In the end, you print answer. Now let's look at the lazy segment tree. So initially everything is uh, long max, saying that nothing is possible to update. Okay. Now in our segment tree, we are going to store the minimum range minimum. Okay. Because given a particular index, we need to push down the minimum elements. So all the values of lazy are initially going to be long max. What is going to be our push function? If lazy node not equal to long max, then ht node is minimum of lazy node comma ht node. And if start is not equal to ending, then we will push it down to its children and then say lazy node is equal to long max. So we won't need to push it again. After this is done, in every query, you just push. And if it is not in the range, then long max. Otherwise, if it is in the range, then you return ht node. And then given two sides, you just return minimum of q1 comma q2. Even in update, you push this, this remains the same. This also remains the same. The only thing that changes is when you're given a range and you want to update it, lazy node is equal to minimum of lazy node comma value, and then you just push for that particular node. And that is all. Like it's a very simple solution. The only thing you need to realize, like the only hard part is how can we optimize from O of n square to O of n log n? And this can be done using a lazy segment tree. Were you guys able to understand the solution? Amazing. So it's kind of dynamic programming plus segment tree solution. If you're preparing for ICPC or similar contests, I would definitely recommend that you look at these ideas where you use segment tree and dynamic programming. I hope you liked today's post contest discussion. If you did like, please feel free to drop a like and comment. See you guys next time. Till then, bye bye. Thanks a lot for joining in. Have a great day ahead.